In our previous video, we proved that if we had a parallelogram like this, then the diagonals of this parallelogram. So let me draw one diagonal in white and the other diagonal in green. So we had proved that the white diagonal bisects the green into two equal halves, and similarly the green one bisects the white into two equal halves. So this is what was proved in our earlier video. That is, the diagonals of a parallelogram bisect each other. Now what would be the converse of this theorem? How can we state the converse of this fact which has been stated above? So here we do not have a parallelogram. We do not know whether the four-sided figure given to us is a parallelogram. So let me draw a rough four-sided figure. But the only thing which we know is that the diagonals of this four-sided figure. So once again, let me draw the white one and the green one. So what the result was in the first theorem, in the earlier theorem, that given any parallelogram, the diagonals bisect each other. But here, the diagonals of this quadrilateral are already bisected. They are into two equal halves by the other diagonal. The white diagonal is bisected into two equal halves by the green one, and the green one is also divided into two equal halves. Now, can we conclude that this quadrilateral is a parallelogram? So this statement, if stated properly, would be the converse of the diagonals of a parallelogram bisect each other. So let me try and state the converse first. So if the diagonal, so what is given? Let me state first. If the diagonals of any quadrilateral, if the diagonals of a quadrilateral bisect each other. So this is given to us. Bisect each other. Then the quadrilateral or it is a parallelogram. So let us try and prove the converse in this video. So let me consider the same brown figure now. Let me call it ABCD, because in order to state all these congruent triangles, because by the means of congruent triangles only we can establish the opposite sides are equal or opposite sides are parallel, etc. So we'll try and establish the congruence of these two triangles which are formed, AOB and COD. So first let's see whether they are congruent. So let me consider triangle AOB and triangle COD. So what do I observe in AOB and COD? First thing, AO is OC, right? These two, AO is equal to OC, or let me use the black color here. So these two are equal, and similarly these two are equal. So we have two sides of these two triangles equal, and if you look at the figure, the two intersecting lines form two vertically opposite angles, so the angles also are equal. So we can conclude the congruency of these two triangles by SAS, side angle side congruency criteria. But by establishing congruency, what have we achieved? Now, what is to be proved? Let me state properly. What is given to us is AO is equal to OC and DO is equal to OB. These two are what is given to us. The diagonals bisect each other in this quadrilateral. And what do we have to prove? To prove that the opposite sides are parallel, because that shows that it is a parallelogram. You will have to prove that AB is parallel to CD, and you will have to prove that AD is parallel to BC. So in order to prove parallel lines, we will have to establish that the interior angles, the alternate interior angles are equal. So can we say that if AC is the transversal, can we say that these two angles are equal? Yes, it appears so, because triangle AOB and triangle COD are congruent one another. So the angles in white are equal, and at the same time the angles in brown also are equal. So I can say that AB is parallel to CD, right? And if I consider these two triangles, AOD and BOC, I can also, by the same argument, because the two sides, the corresponding sides are equal and the vertically opposite angles are equal, by the same argument, I can also say that AD is parallel to BC. So the figure ABCD is a parallelogram. So we have proved the converse. The converse of this theorem has been proved.